So the PEP competition, as much as it's a speed race, it's a reliability competition. That we have 5 Navy boats that are going to be with us on race day because we're going to tow a bunch of you all off the course. And it's not that you ran out of battery necessarily. In fact, that happens fairly uncommonly. It's because something became loose, something that wasn't connected anymore, and it just wasn't as reliable as it needed to be. But when you have a well-structured boat with places that things are supposed to go, that have ways to like secure wiring and things like that, like you all have, it makes it a lot better.
Yeah, I think in the case of our newer boat, the Trimaran, we didn't build it from scratch. We started off with 3 hull pieces, basically. But all of the connecting, all the cockpit, all of that central area, we did fabricate that. And it was a challenge and it was a lot of work to do that. But the benefit is that we knew exactly what components were going to be going in there. And we could build things that were more integral to those components as opposed to, this is the amount of space that's currently there. Where can we make this battery fit? How can we make this thing adapt to best fit that space? And so in the case of a catamaran like that, they typically have an aluminum pipe that goes across the front and the back of the boat, basically, and that's what the trampoline was connected by. We ended up taking that forward pipe out, and we integrated all Cusa board as the coring material, and then fiberglass all across there. And the reason we did that was because we wanted the batteries to be where that pipe was. We could have put it in a different position, but we did testing in advance, knowing how the boat, how it sat in the water with weight in a certain distribution. We knew that if we had the batteries behind the pipe, it was too far aft, and if we put them forward, we stood the chance of being a little bit too front heavy. And the last thing we wanted was to be going really fast and bury the bows and have it somehow, pitch pull, which could be obviously very dangerous to be doing.
Right.
So we ended up building the way that boat is constructed, being that it's got 3 battery banks. Each of the 3 compartments are watertight. They're isolated from each other. They are connected electrically, but they have solenoids that can disconnect them. And I guess we'll talk more about batteries in a second. But
sure,
that was something we were able to design into the boat to make it sort of fit just exactly what we need. So, but one of the things, going back to the first year we competed at PEP with the wooden hulled boat, because we had been competing previous to that in the Y Island Challenge, which is a different race. That's a 24-mile endurance race. And with that race, our battery bank was not quite big enough to run at full speed the entire time, and we knew that. So if we had done that before. The downside to doing that is you get 3/4 of the way around the race, and then you realize we're not going to be able to finish at this pace, and then you drop back significantly and creep along, at that reduced pace. But the most efficient, the best way to go fast to your destination is to measure it out, to be able to consume mostly all of your battery with a slight reserve right at the finish line, as opposed to going as fast as you possibly can and then realizing somewhere around the course, if you want to be able to finish that race, you got to throttle back a lot, and you're going to end up doing worse than you would have if you found that sweet spot.
Sure.
But in preparation for PEP, we took it out and we ran it full speed for 5 miles, and we were watching the engine temperatures. And, I don't know if we know that we would have overheated it in a sense, but we didn't like how hot everything was getting, and we didn't know at what point would we have a problem. And there was an easy solution, which was, let's improve our cooling, So we had an air-cooled brushed DC motor, and our controller had minimal cooling on it as well, because at the point, the way we were using it, it wasn't needing much more than passive cooling. So the students, for the controller, they devised a pancake fan, sort of adapter that mounted on the bottom of the controller to, kind of help distribute the heat coming off the heat sink and get it out of that case and everything like that. But for the motor, it was actually more dramatic of a change, because we went from being air-cooled to, it still was air-cooled, but we added a water cooling jacket around it that the students fabricated it to, wrap the whole thing with a water cooling jacket to get the heat off of it. And then the process of doing that, we experimented with we were talking about, like, what should we use for our cooling? Should we use raw water or fresh water? We ended up saying, the idea of not pumping, raw water through it, to not take a chance of having something clog it, because then you go from cooling it to zero cooling if you clog it up, and the reliability aspect of it. And we also toyed with the ideas of things like using dry ice and something that would
Sure.
not freeze, at those lower temperatures. But then we were skeptical about, all of the tubing and all of the pieces that had to remain flexible as the engine would be steering and connecting our reservoir to that and everything. And we ended up just going with ice water,
Yeah,
which worked
yeah.
really well.
Right.
And for a longer race, it maybe wouldn't make sense because at the end of a 5-mile race, you go from a bucket of cold ice water to lukewarm water, and it gets to
Sure.
the point where you're starting to heat it up to a point where the heat isn't getting out of that bucket fast enough. But for
Right.
5 miles, it was a great
Yeah, and I
great
think
thing to do.
for first year teams, right, like you're going to find your heat issues pretty late in the game. So like this is something you're probably going to be needing to address in like March, April, unfortunately.
And so you want to use the boat like you're going to be using it in the race.
Right.
Just don't go out and see how fast can I go if I floor it for 5 seconds. Like you want to see. I have to run it the way you would be running it in the race.
Yeah.
Go out, go back and forth around a course, do 5 miles, do a little bit more than 5 miles to see how close to that threshold were you. You really want to know how close you were to failure. And if you're going to fail before it means that you just had to bail out of the race. If
Yeah.
it's something you can fix, so you can change in advance, you can afford to make the mistakes earlier on and revise your approach.
And when we're trying to figure out your motor, you can test that on a bench. You don't necessarily need to be in the water. And then if your school hasn't done a lot of naval testing before, you may think it seems like this huge thing where you got to get to a lake. But if you can just put a strong rope or 3 on the back of your boat and go in the opposite direction, that's how we test. That's what an in-water test looks like. So it doesn't mean that you have to necessarily have ice-free water to be able to test your boat. You can always be doing that through the year.
Yeah.
But
And if you're electric, you could potentially put it in a pool as long as it's not going
Yeah.
to go crashing into the side of the pool or something,
Sure. No, that's exactly right.
Indoor pool, so.
Yeah.